This is 5.1, lesson 2. So for this lesson, we are going to graph systems of equations. And these equations are going to be in slope-intercept form, meaning it's going to be in that y equals mx plus b form. So a system of equations allows us to find the point where two linear equations cross. The solution is the point that works for both equations.
Colton Shepherd to the counselor's office, please.
Where is the point on the graph? This point is going to be where the lines intersect, or where they cross. Will two lines always cross? So we think about two lines, they may not always necessarily cross. If I draw a line like this and a line like this, and I were to continue those for forever, they're never going to cross, okay? So what are the possibilities? Possibilities are that they never cross, which means that they're parallel, or it could be the exact same line, so they cross for the entire graph. Okay, so our first example, we have two equations here. Our first equation is y equals -5/3 x plus 3. So for this equation, we're going to begin with our b, which is 3. And then our m is going to be -5/3, which means that we are going to go down 5. 1, 2, 3, 4, 5. And then we are going to go right 3. 1, 2, 3. And that's going to be our new point. Let's see here. If I go down 5, 1, 2, 3, 4, 5, and right 3 again, I can do that. I cannot go up 5 and left 3 again, though. So then we can go ahead and draw our line for this equation. This is our first line. Then our second line begins at -3. So it's right here. And then our slope is a rise of 1 and a run of 3. So that means we're going to go up 1 and then right 3, which gives us this exact same point right here. And I can go up 1 and over 3 again. Same thing with going the other direction, 1, 2, 3. Since I already know the point of intersection, I'm fine if you don't quite finish out the line or finish out the points for the line. We'll draw our line all the way through. Now our solution is going to be the point where they intersect. So the point where they intersect is this point right here. It is 3, -2. Okay, now we're just going to double check that this is the solution. So in order to double check this is the solution, we're going to plug in 3 for our x and 2 or -2 for our y in both equations. So our first equation will be -2 equals -5/3 times 3 plus 3. Okay, so this is going to give us -2 equals -5 plus 3. -5 plus 3 is -2, so that one works. And then our second one, we're going to have -2 equals 1/3 times 3 minus 3. 1/3 times 3 is 1. And 1 minus 3 is -2, so that also works. So that's our way that we check that our ordered pair is in fact the correct solution. Number 2, whenever we graph this, our y-intercept is going to be 3. And then our slope is 4, but we want it as a fraction. So we're going to rise 4 and run 1. Again, we can go in the opposite direction. We can go down 4 and left 1. And then draw our line. Our second equation, our y-intercept is -2. And this time our slope is going to be -1 over 1, which means that we are going to go down 1 and then right 1, which gives us this point right here. We could continue to go down 1, right 1, but if we go the opposite direction, we will see that when I go up 1, left 1, it gives me this intersection point right here. Again, I can continue just to help with drawing my straight line. So our solution is going to be this point right here, which is the point -1, -1. So when I plug this into my equation, my first equation, I get -1 equals 4 times -1 plus 3. 4 times -1 is -4 plus 3 gives me -1. So that works out. And then my second equation, I have -1 equals, I have the negative from in front of my x, then I have a negative because it's a -1 minus 2. Well, when we have our double negative right here, it's going to give us a +1 minus 2. And +1 minus 2 equals -1. We have the same thing on both sides, so this works out. Now, something to give us a quick overview, and we'll get more into this later on, is our special cases. Okay, so we have different numbers of solutions. The two problems that we just did had exactly one solution. That means they intersect at exactly one point. That is the only ordered pair that works. Okay, our next one is an infinite solution. I know it's hard to tell from your picture here, but you actually have two lines graphed here, but they're right on top of each other. So if two lines are right on top of each other, that means every single point works for both equations. So that's going to be an infinite solution because all ordered pairs work. Then over here we have parallel lines. And when we have parallel lines, they're never going to intersect, which means there's never going to be a point that works for both equations. So this is our no solution situation.